Here in 11.8 we're going to be doing what's called factoring by grouping, which you can see as you read the paragraph in blue here. We've already been doing the factoring by grouping in our previous sections. And we're going to take that idea and we're going to apply it to be able to factor by grouping other larger degreed polynomials, such as a cubic polynomial that we see here in this first problem. So if you look at problem 1, we've got 3n cubed minus 12n squared plus 2n minus 8. And by factoring by grouping, we're again looking at the first two terms as a group and the last two terms as a group. And we're able to factor out a 3n squared from the first group and a positive 2 from the second group, leaving us our common factor of n minus 4. And then factoring out that common factor, we've got n minus 4 and 3n squared plus 2 as our two factors. So it's the same principle that we were using in factoring those other quadratic trinomials, just being applied to higher degrees. So if we look at another example here, we've got 8t cubed plus 14t squared plus 20t plus 35. So if we look at the first two as a group and the last two as a group, and we think about what do 8t cubed and 14t squared have in common. Okay? And we're able to factor out a 2t squared from each of those terms. And that would leave a 4t and a plus 7. If we look at the second group of 20t plus 35, we can see that we can factor out a 5 from each of those groups. And that's going to leave a 4t and a plus 7. So we've got a 4t plus 7 as our common factor, 2t squared plus 5 as the stuff that's left behind, and there's our factored form, just like we were doing before. Okay. We could sometimes factor to find possible expressions for length, width, and height. So when we were doing the quadratics, knowing that they only had two factors, we were doing a lot of problems involving the area of rectangles and squares. When we talk about a cubic, that's three factors, so we can expand that to 3 dimensions and start talking about volume, with volume being the length times the width times the height. Okay? So we're able to use factoring to figure out expressions for the length, width, and height of the volume of this rectangular prism that we would have when this wooden toy is all folded up together. And notice in the first step, we are taking and factoring out an x, okay, knowing that volume is length times width times height. We should end up with 3 factors. So this x is going to give us one of those factors. Okay? And then we're going to look at factoring the 6x squared plus 19x plus 15. Okay? So when we look at that, we've got that factor of x, leaving behind the 6x squared plus 19x plus 15. So now we go back to our other methods. We're going to take a times c, and 6 times 15 is going to give me 90. And I need factors of 90 that add up to 19, so I'm looking at 10 and 9. So I have x, then I'll have 6x squared plus 10x plus 9x plus 15. And now we're back to the same factoring by grouping that we were doing before, looking at first two terms and last two terms. So the x is still there, we just carried along. The 6x squared plus 10x, I can factor out a 2x, which will leave 3x plus 5. 9x plus 15, I can factor out a 3, which will leave 3x plus 5. So I have an x, a 3x plus 5, and a 2x squared plus 3. And those would give me my dimensions. I could say that the length is x, the width is 3x plus 5, and the height would be 2x squared plus 3. And those are possible dimensions of our rectangular polynomial. Okay? So tomorrow in class, make sure you have your books, and we're going to do some practice problems out of the book in class tomorrow.